effect of pressure on equilibrium constant.
Right. So any questions on what we did yesterday?
सर वो सभी रिएक्शंस के लिए वो वैलिड होगा ना?
गैस फेज के लिए सिर्फ वो, इट्स ओनली फॉर गैसेस, not for liquid and solids. We'll see that.
Okay.
Because we have assumed that is ideal gas, right? So it is applicable only for the gas phase reactions. Any other question? Okay, anyway, I'm going to repeat it because that's an important topic and you need to understand it. Let's see. Okay, so we started looking at effect of pressure on K, which is equilibrium constant. And we know that by definition delta G0 is minus RT ln K. And delta G0 is in standard state, which is defined for gases as low pressure or almost 1 atmosphere pressure. So in that case, there is no effect of pressure on K value because we are talking about standard state. So K is given by equation 1 is independent of pressure because we are talking about standard state now, right? But K is a function of temperature because this equation has temperature. So if temperature changes, K will change, right? And K is defined as given by equation 1 in terms of activity of each component, product upon reactant. Any questions on equation 1 and effect of pressure on K before we proceed further? Okay, let's proceed. So although there is no effect of pressure on K, there is an effect on composition because K is equal to some function of composition, right? So K affects equilibrium composition or pressure because we have seen K we can define in terms of Ka, Kf, Kp, right? So when we talk about Kp, we are talking about partial pressures, right? And we know that if you take ideal gases, Pv is equal to nRT and N by V is equal to P by RT. That means if the pressure changes, concentration changes or composition changes, right? C is equal to P by RT that we had seen last year also in PC. So if you talk about pressure change, that is in a way talking about composition change, right? Any doubts on this? What on this concept? Okay, so what is Lee-Chatelain's principle? We had seen before. What is Lee-Chatelain's principle? Who can tell me? याद है किसी को Lee-Chatelain's principle? Nobody remembers, is it? We had seen it for temperature before, when we saw the effect of temperature.
The reaction proceeds. The reaction proceeds in the direction where the number of moles are less.
No, not exactly. You are talking about a specific case. Lee-Chatelain's principle is very general, which says that if I introduce a kind of disturbance on a reaction, like if I increase the pressure, right? If I increase the temperature or pressure, the reaction will proceed in such way to minimize the effect of that disturbance, right? If I try to increase the temperature, the reaction will proceed in such a direction that it reduces the temperature. If I increase the pressure, the reaction will proceed in such a direction, because we're talking about reversible reaction, right? Forward direction and reverse direction. So if I increase the temperature, that reaction will take place, which will reduce the temperature, because it's trying to balance the disturbance. Whatever disturbance I give to the reaction mixture in terms of temperature or pressure, the reaction will proceed in such a direction that it minimizes that effect. That is the principle of Le Chatelier. Is there any question on that? इतने लोग को समझ में नहीं आया ये, because that is the basic what we're going to discuss now. In Unit 6, quite a lot of time we'll be discussing about this. कितने लोग को समझ में नहीं आया ये? Raise your hand. Only one person. बाकी सबको समझ में आ गया?
सर
Yes,
Yeah.
सर वो जो मैंने बोला ना नंबर ऑफ मोल्स वाला, तो वो कंडीशन सिर्फ प्रेशर के लिए होगी?
Yeah, pressure के लिए होगी. If I try to increase the pressure, right? There's a specific case. If I increase the pressure, the reaction will proceed in such a way that it reduces the pressure. Reducing the pressure means reducing the moles. It's a very specific case of Le Chatelier's principle. It's not wrong. It's a specific case of Le Chatelier's principle. You're right. But I was talking about a general statement of Le Chatelier's principle, which says that if I say, like in the class, you remember PC mein, I used to ask you to stay quiet, right? And when I turn around to the board, you will start talking, right? So I was trying to enforce discipline. चुप बैठो, और अब मैं थोड़ा पलटा तो बात करना चालू हो जाता है. That is in a way Le Chatelier's principle. But we are talking about temperature and pressure here. Concentration भी रहेगा. Anything, any disturbance, anything I impose, any disturbance or change which I introduce in a reaction or a reaction mixture in terms of temperature, pressure, concentration, जो भी रहेगा, it will try to reduce it, it will try to oppose it by going in that direction which is reverse of that. Right? We saw that अगर exothermic reaction है, what happens in exothermic reaction?
Heat is evolved.
Heat is
sir,
evolved.
heat evolved.
Right? So the reaction will proceed in such a way so that heat is absorbed. उल्टा होना चाहिए. Right? Right? Or heat is required. वो कब होगा? When temperature is reduced. That is why for exothermic reaction, we don't need maximum temperature, we need minimum temperature. For endothermic reaction, what happens? What is endothermic reaction?
Heat absorbed.
Heat is absorbed, right? So reaction will proceed in such a way that heat is released. उल्टा होना चाहिए बिल्कुल. What is happening is essentially उल्टा होना चाहिए. So that means temperature should be increased. For endothermic reaction, we always operate at maximum temperature because heat is absorbed. Ulta. So if I increase the pressure, the reaction will proceed in such a direction that it will reduce the pressure, oppose the disturbance, oppose the change. Or reduce pressure कैसे होगा? We have seen that. If you look at this equation, ideal gas, P is proportional to N, right? If V is constant and temperature is constant, then P is directly proportional to number of moles. So the way to reduce the pressure is to reduce the number of moles. So if I increase the pressure, the reaction will proceed in such a direction that the number of moles are reduced. That means the pressure is reduced. If I reduce the pressure, the reaction will proceed in such a direction that उल्टा होना चाहिए, right? Pressure increase होने. Pressure increase कब होगा? The number of moles are increased. Is that clear, Praveen Sate? Anybody else has questions on Equilibrium principle before you proceed further?
Hello.
Yeah.
सर अगर रिएक्शन इरिवर्सिबल हो तो?
We are talking about equilibrium. Equilibrium is always for reversible reactions. Irreversible reactions always go to almost 100% completion. जैसे inorganic reactions रहता है, sulfuric acid plus NaOH, उसमें reversible कुछ नहीं है. It always goes to completion. It may take more time, that's a different thing, but it always goes to completion. ठीक है? Any other questions? The sulfuric acid Na2SO4 और water बनता है, right? If you take NaOH plus H2SO4, क्या बनता है? Na2SO4 plus water, right? Reversible reaction and Na2SO4 plus water लिया तो reversible reaction नहीं होता कभी, right? If I take sodium salt or sodium sulfate and dissolve in water, what will happen? Will sulfuric acid be formed? कभी देखा ऐसा reaction inorganic chemistry में? It just dissolves. Na2SO4 will dissolve in water. It's not going to form sulfuric acid and NaOH. So there is no reversible reaction in inorganic chemistry. Mostly in organic also, जैसे ammonia का देखा. Ammonia is again inorganic compound, but that's a reversible reaction, not irreversible. So irreversible reaction में general नहीं रहता. We are talking about equilibrium. So essentially we are talking about reversible reaction कि उल्टा reaction हो सकता है. Both directions reactions.
Okay, sir.
Okay. Any other questions? Okay. Let's now look at this. So Lee-Chatelain's principle says at a system at equilibrium, if it is subjected to a disturbance, it responds in a way that tends to minimize the effect of disturbance, right? If I increase the pressure, it will try to reduce the pressure. If I increase the temperature, it will try to reduce the temperature. Okay? So increase in temperature will shift the equilibrium direction of heat absorption. Decrease कैसे होगा temperature? Right? So when I increase the temperature, the reaction will proceed in that direction, which is endothermic. That means it absorbs the heat. Right? So equilibrium will shift in endothermic reaction, in endothermic direction, if the temperature is increased, because endothermic reaction absorbs heat. Okay? This is what we talked about. And equilibrium shift in exothermic direction if temperature is reduced. Temperature reduced किया तो it will try to increase the temperature. Temperature कब increase? When there is exothermic reaction. Right? समझ में आया ये effect of temperature, endothermic and exothermic?
Yes, sir.
Okay. So endothermic reactions are favored by increasing temperature. That means endothermic reaction कोई भी रहेगा तो we always have to operate at maximum temperature. जितना maximum possible है उतना ही temperature लेना चाहिए. Whereas exothermic reaction is favored by decrease in temperature. So we operate at very low temperature as far as possible. Conversion होना चाहिए, but it should not be very high temperature. Right? Or increased temperature favors reactants in exothermic reaction. When you say reactants, let's write it down. Okay. Effect of pressure. Okay. So when you talk about reactants, if this is exothermic reaction, power reaction, reverse reaction will always be endothermic reaction. right? So the increased temperature reactant, that means it will proceed in this direction in exothermic reaction, because this is endothermic reaction, reverse reaction. Whereas it favors product, means ये जो है endothermic reaction में, suppose it is endothermic, then reverse reaction will be exothermic, right? So if you take exothermic reaction, it will always go in this direction if you increase the temperature. And if you take endothermic reaction, it will always go in this direction if you increase the temperature. Is this understood? Okay.
Yes.
Okay. So now let us take another example. A gives 2B. So when you look at this reaction, 1 mole of A gives 2 moles of B, right? So when we increase the pressure, the reaction will respond in such a way to minimize the effect of increase in pressure, right? How will it decrease the pressure? By going in reverse direction, because its number of moles are decreasing, right? We've seen that PV is equal to nRT. We were talking about ideal gases or gas phases. We assume ideal gas. That means pressure is directly proportional to number of moles, keeping when temperature is constant, V is constant, right? So this is achieved by decreasing the number of moles by which reduces number of moles, which is achieved by reverse reaction. So if I increase the pressure in this reaction, it will try to go to reactant, that means conversion कम होगा. So forward reaction is favored by, okay, if I take 2B, if I take the reverse reaction, 2B goes to 1, 2B goes to A, then forward reaction, this is forward reaction, this is the reverse reaction, right? Then it is favored by increase in pressure because number of moles are reducing, and reverse reaction is favored by reduced pressure because number of moles are increasing in the reverse direction. Okay, any questions on effect of pressure? Okay, if there are no questions, let us proceed further. So increase in pressure decreases number of B molecules, right? B molecules here, right? In this reaction, it try to reduce the number of B molecules. How will it reduce the number of B molecules? By doing the reverse reaction. And increase number of A molecules. Reverse reaction होगा तो, ठीक है? So now let's take the example of ammonia. Nitrogen plus 3 hydrogen gives 2 moles of ammonia. In the feed we have 4 moles, and in the product we have 2 moles, right? So that means in the forward reaction, forward direction, number of moles are decreasing, 4 से 2 हो रहा है, and the reverse direction, number of moles are increasing, 2 का 4 हो रहा है, right? And we know that 1 mole of nitrogen reacts with 3 moles of hydrogen to give 2 moles of ammonia, right? So if you increase the pressure, what will happen in this case? What will happen in this case if you increase the pressure?
Reversible.
फॉरवर्ड रिएक्शन
रिवर्सिबल किसने बोला? किसने बोला था रिवर्सिबल?
सर मैंने
दिख नहीं रहा है नाम, किसने बोला था? हाँ,
प्रवीण
प्रवीण, तुमको समझा नहीं इफेक्ट ऑफ प्रेशर अभी तक? When we increase the pressure, the reaction will proceed in such a direction to reduce the effect of pressure. That means it will try to reduce the pressure. यहाँ पर pressure कब reduce होगा? When number of moles are reduced. Number of moles किस direction में reduce हो रहा है? Forward के reverse?
फॉरवर्ड डायरेक्शन. यस सर.
Forward direction. So the reaction will proceed in the forward direction. If I increase the pressure reduce किया तो क्या होगा? It will try to increase the pressure. बराबर? How will it increase the pressure?
Sir, in reverse type.
By increasing the
sorry.
number of moles, right? Increasing number of moles
Yes.
means reverse reaction. Right? That's what I said here. When I increase the pressure from 1 atmosphere to 100 atmosphere, as pressure increases, number of moles increase, right? So it will try to reduce the pressure. The Chatelet's principle, right? Pressure increase किया तो it will try to reduce the pressure. कैसे reduce करेगा? By reducing number of moles. And it will go in the forward direction. That's why ammonia production is at what pressure? CPT में पढ़ा है ना आप लोगों ने? What is the pressure of ammonia reactor?
200.
200 atmosphere. This is very high pressure. It's not low pressure. It is very, very high pressure because high pressure favors the formation of ammonia. जितना high रख सकते हैं, there is a limitation. Other constraints are there कि equipment कितना pressure ले सकता है, कितना high pressure sustain कर सकता है equipment. So there are other constraints, engineering constraints. So we cannot go to very, very high pressure, but yes, as high as possible under the constraints of the equipment. We try to keep for ammonia. ठीक है? The number of moles reduces when ammonia is produced. Therefore, formation of ammonia is favored by increase in pressure. Okay, so when changes in response to increase in pressure, it does not change K, right? Because K is equal to some function of pressure. We've seen that, right? We'll see that again. Kp defined किया था हमने. What is Kp? What is Kp? याद है किसी को? नहीं याद किसी को? ये बेसिक डेफिनेशंस याद रहना चाहिए आपको. Right? Pi of pi bar raised to power of nu I, right? और इसका इक्वेशन पता है क्या होता है? प्रोडक्ट अपॉन रिएक्टेंट. सो रिएक्टेंट प्रोडक्ट का ऐसा के पार्शियल प्रोसेस ऐसे चेंज होगा सो दैट के इज कांस्टेंट. But equilibrium concentration in liquids or solids or solutions are not affected significantly by changes in pressure. Right? हमारे यहाँ प्रेशर में देखा इफेक्ट ऑफ प्रेशर देखा भी आपने, राइट? इट चेंजेस concentration वगैरह. But for solids and liquids there is no effect of pressure. Okay, so now let us see how to calculate concentration when the pressure changes. So K is defined as by this equation, which is pi of AI to the power of nu I is nothing but product का activity raised to power of stoichiometric coefficient divided by reactant का activity raised to power of stoichiometric coefficient. Okay, so activities are components affected by change in pressure, temperature, and composition. We have seen this, right? Daba A by daba P, daba A by daba T वगैरह देखा, right? Effect of temperature and pressure on activity. But K is independent of pressure. Activities are not. The activities change with pressure so that K does not change. Overall effect is that K does not change, but so we had defined different forms of K. K is equal to Kf, which is nothing but pi of phi I bar raised to power of nu I, and this is for ideal gases using standard state as low pressure. And we have also defined phi I, which is vigorosity coefficient, which is Fi bar divided by Pi bar, which is nothing but Fi bar upon Yi into total pressure. So Fi bar is equal to phi I into Yi into P. And if we substitute in this above equation, we get K is equal to Kf phi of Fi bar की जगह पर phi I P raised to power of nu I. We can split this and we get K is equal to pi of phi I bar raised to power of nu I, pi of Yi raised to power of nu I, and pi of P raised to power of nu I. right? And we defined nu as summation of nu I, which is nothing but L plus M minus A minus B. And if you look at pi of p raised to the power of nu I, this is equal to this term, which is p raised to the power of m, which is product coefficient, total, it is pressure, and p raised to the power of L upon p raised to the power of A and p raised to the power of B, which is nothing but p raised to the power of L plus m minus A minus B, which is nothing but nu. So we'll get equation 1, which is k is equal to pi of phi I raised to the power of nu I into pi of y I raised to the power of nu I into p raised to the power of nu. Any questions on equation 1? Okay, if there are no questions, let us proceed. And we know that k phi is equal to pi of phi I raised to the power of nu I and ky is equal to pi of y raised to the power of nu I. So what you get is k is equal to k phi into ky into p raised to the power of nu. And we know that ky is nothing but mole fraction of product raised to the power of stoichiometric number divided by mole fraction of reactant raised to the power of stoichiometric number. So ym raised to the power of m, yl raised to the power of l divided by ya raised to the power of a divided by yb raised to the power of b. So ky is the equilibrium constant in terms of yi or composition. Y is nothing but mole fraction, which is composition. Right? And we have also seen that for reactions, for reaction mixtures which behave the ideal gas, k phi is equal to 1. Right? So what you get is k is equal to ky into p raised to the power of nu. Equation 3. Any questions on equation 3? Okay, so since k is independent of pressure, variation in p raised to the power of nu term is balanced by change in value of ky, right? Because this is constant. So if ky increases, p has to decrease. If ky decreases, or p raised to the power of nu, p raised to the power of nu has to increase. Ulta होगा, because k is constant, left hand side is constant. So right hand side में दो term है, x into y or a into b. So if a increases, b decreases, b increases, a decreases. समझ में आया? इक्वेशन 3 का इफेक्ट क्या होगा? So change in ky is essentially it lead to change in equilibrium composition. Ky increase हुआ तो p raised to the power of nu decrease होगा. p raised to the power of nu decrease हुआ तो ky increase होगा. Okay. If decrease the number of moles during reaction, for example, ammonia production, which is 4 moles giving 2 moles, then nu is negative, right? The power of pressure, total pressure is minus हो जाएगा. In this case, it is -2 for ammonia. Therefore, the increase in pressure will decrease p raised to the power of nu, which is p raised to the power of -2, right? प्रेशर बढ़ाया तो ये टर्म रिड्यूस हो जाएगा. That means ky should increase, right? Therefore ki and hence equilibrium yield will increase. That means ki increase हुआ तो क्या हो जाएगा? Ky is nothing but y ammonia whole square divided by y nitrogen divided by y hydrogen whole cube. So ky increase हुआ, that means ammonia increase होगा. Any questions on why ammonia concentration will increase when we increase the pressure? Woollich at least principle से देखा था, that was conceptually, but now mathematically also we can show that when we increase the pressure for ammonia production, it will favor the formation of ammonia, that is a forward reaction. Anybody has any questions? Because this is how we are going to analyze. We're going to solve many problems where we see what is the effect of pressure on reaction. No question. Let us proceed. The reaction leads to increase in number of moles, right? जैसे a raised to a gives 2b देखा था हमने, right? So in that case, nu is equal to +1 हो जाएगा, 2 minus 1. So nu is positive, and equilibrium yield or composition will decrease with increase in pressure. That means अगर p raised to power of nu पॉजिटिव है तो ये टर्म पॉजिटिव रहेगा, ये पॉजिटिव रहा तो ये इंक्रीज हुआ, प्रेशर इंक्रीज हुआ तो ये इंक्रीज होगा, ये इंक्रीज हुआ तो ky डिक्रीज होगा, ky डिक्रीज हुआ तो essentially it will favor the reactants, तो रिवर्स रिएक्शन होगा. So this equation can explain Le Chatelet's principle. हम देखा Le Chatelet's principle conceptually देखा. Now this equation helps us explain what Le Chatelet's principle says. So this is a mathematical expression for, you can say, Le Chatelet's principle. Any questions on equation 2 and how to use it to explain Le Chatelet's principle?
सर
Yeah.
सर अगर कोई रिएक्शन में रिएक्टेंट और प्रोडक्ट के नंबर ऑफ मोल सेम है और अगर हम प्रेशर बढ़ाएंगे तो क्या होगा इफेक्ट?
Excellent question, शिवानी. Excellent question. क्या होगा बताओ?
सर नहीं पता.
इक्वेशन 2 में क्या बोलता है? अगर रिएक्टेंट और प्रोडक्ट का सेम है मोल्स तो क्या होगा? न्यू क्या हो जाएगा?
0
0 हो जाएगा. तो व्हाट इज द इफेक्ट ऑफ प्रेशर?
नहीं होगा.
नो इफेक्ट ऑफ प्रेशर. एग्जैक्टली. एक्सेलेंट क्वेश्चन. वो सोच रहे हैं, यानी लगता है कि सोच रहे हैं कुछ लोग. फील वेरी हैप्पी कि कुछ लोग सोच रहे हैं, कुछ बहुत लोग तो सोते हैं. बट इफ समबडी लाइक दिस आस्क्स अ क्वेश्चन लाइक दिस, आई एम वेरी हैप्पी. थैंक यू शिवानी. ठीक है, समझ में आया? सो इफ देयर इज नो चेंज इन नंबर ऑफ मोल्स, if 2 moles of reactant give 2 moles of product, then nu is equal to 0. Nu is equal to 0. That means in this equation, equation 2, p raised to power of 0. You take any pressure, कितना pressure बढ़ाओ कम करो कुछ भी करो, कुछ नहीं फर्क पड़ेगा. ky will remain the same. And this is not explained by Le Chatelet's principle. It is explained by this equation only. Anybody has any questions? Okay. So this equation can also explain the effect of P when nu is equal to 0. Exactly same point of Shivani raised किया. When nu is equal to 0, which cannot be explained by Le Chatelet's principle. Le Chatelet's principle does not say anything कि अगर pressure change नहीं किया, कुछ disturbance नहीं किया तो क्या होगा. It just says कि disturb किया तो उल्टा होगा, उसको oppose होगा. But when there is no disturbance, when there is no change, there is no change in number of moles, तो क्या होगा. But this equation explains it very clearly कि अगर नंबर ऑफ मोल्स कांस्टेंट है, रिएक्टेंट और प्रोडक्ट का सेम है, तो देयर इज नो इफेक्ट ऑफ प्रेशर. ओके. सो इफ यू टेक दिस रिएक्शन CO plus water giving CO2 plus H2, which is water gas shift reaction, effect of pressure on this reaction can be explained by effect of pressure on K phi. K phi पे देखना पड़ेगा, right? We have set K phi. If K phi is 1, then there is no effect. Right? K phi measures deviation from ideal behavior, hence effect of pressure. आइडियल गैस के लिए नहीं होगा, बट अगर प्रेशर बहुत बढ़ गया हमारा, if the pressure is very high, then ideal gases cannot be assumed, and that will come through K phi, gasicity coefficient, right? At low pressures or at reasonable pressures, K phi we can assume 1, but अगर बहुत high pressure होगा तो K phi का effect होगा. ठीक है. So if K phi decreases, Ky will increase, right? And hence equilibrium yield will increase even if nu is equal to 0. So nu की तरफ से नहीं आएगा, but नॉन आइडियल की वजह से इफेक्ट आएगा. and effect of pressure on K5 can be calculated from viscosity coefficient. हमने calculate किया था, right? We have done these calculations. I think in unit 3 था, right? Okay. So when compressibility of products is greater than compressibility of reactants, K5 decreases with pressure. Z is nothing but PV by RT, right? PV is Z is equal to P into V real upon RT. So if the compressibility is more than the reactants, then K5 decreases pressure and therefore Ky increases, conversion increases. This is the observation, right? And we have seen how to calculate phi. ये question था अपना, right? Using compressibility. ln of phi is equal to ln of f by p integral 0 to pz minus 1 by p into dp. So there is a way to find out what is the effect of pressure for very high pressures when the non-ideality kicks in. Ideal gas के लिए there is no effect of pressure for nu equal to 0, but for non-ideal cases it will happen. ठीक है? Any questions? शिवानी, आपका आंसर क्वेश्चन आंसर हो गया? Okay. Any questions on this?
Sir, how does K5 decrease with pressure in this case?
Okay. Because K5 is what? K5 is तो सबका कैलकुलेट करना पड़ेगा और देखना पड़ेगा, बट दिस इज एन ऑब्जर्वेशन, राइट? There's only way to know actually calculating it, but this is observation based on whatever research they have done. K5 decreases with pressure. If you remember, हमने देखा था, right? When you calculate phi, if you calculate phi for 100 R, तो कितना आ रहा था values roughly? प्रेशर का और phi फिगसिटी का या phi का किया था हमने calculations, right? We had done some calculations. Was it more than 1 or less than 1? ठीक है, so I think it was mostly less than 1, but ठीक है, ultimately we have to see कि ये calculate करने का phi and then you can calculate K5. ठीक है, any questions on this? It's a calculation और कुछ नहीं. I don't have any other explanation for why K5 decreases pressure.
Okay, sir.
अगर मिला explanation तो बताऊंगा next time आपको. We will try to see if there is an explanation for that conceptual level. Okay. ठीक है. Any other questions? Proceed to next topic. Okay. So there are other factors which affect equilibrium conversion. Reaction conditions which affect equilibrium conversion or extent of reaction are temperature देखा हमने already, calculations भी किया हमने, effect of temperature on K, and we have just now seen what is the effect of pressure on K or equilibrium conversion, Ky. Now we'll see what is the effect of inerts and what is the effect of presence of excess reactants, because हमने देखा था, right, last year PC में. In many reactions we have excess, like if you burn, air is always an excess, 10%, 15%, 20% कुछ तो excess डालते हैं, right? So one of the reactants is in excess, one is limiting reactant. That's why we define limiting and excess reactants. Okay, and finally we'll see what is the effect of presence of products of reaction in initial reaction mixture. Suppose that ammonia production में suppose if feed contains some ammonia instead of pure nitrogen and hydrogen, suppose it contains some ammonia because nitrogen hydrogen पूरा react नहीं होता है, so we recycle it. Unreacted nitrogen hydrogen is recycled and that's why थोड़ा ammonia आ जाता है उसमें, right? So if the feed contains ammonia, then what happens? Okay, so we have seen equation 2, K is equal to K phi into Ky into P raised to power of nu, which we can write as rearrange it, Ky एक side लेके आने का. So what you get, Ky is equal to K upon K phi, and if you take P on the other side, you get P raised to power of minus nu, equation 4. And Ky is nothing but pi of yi raised to power of nu I, and yi is nothing but number of moles of component I divided by total number of moles. So it is pi of Ni divided by total moles raised to power of nu I, where n is total number of moles including inerts, because we want to talk about inerts now. So inerts आएगा. So n is nothing but summation of nu I, all the reactants, Ni is reactants, plus number of moles of inerts. Okay, so if you put in this one, K is equal to pi Ni to the power of Ni by n raised to the power of nu I. If you substitute, if you separate it, you get pi of Ni to the power of nu I and pi of 1 by n raised to the power of nu I. Right? इसको separate कर दिया, numerator denominator को दो terms बना दिया. And we know that nu is equal to nothing but summation of nu I. So you can write Ky is equal to, this is n raised to the power of minus nu हो जाएगा, because you're talking about pi, that means numerator में products आएगा, denominator में reactants आएगा, so it is n raised to the power of minus nu, summation of nu I, into pi of Ni raised to the power of nu I. ठीक है? Is this understood? This term कैसे आया ये? Okay, so if it is understood, then right hand side is nothing but whatever you had in equation 4, K by K phi into P raised to the power of minus nu. So we can write this as keeping some terms on the left hand side, that is pi of Ni to the power of nu I left hand side में रखा और n नीचे लेके आ गए इधर साइड में, n raised to the power of minus nu इधर लाया तो n raised to the power of plus nu हो जाएगा, by K phi n by P raised to the power of nu, right? Because P raised to the power minus nu था तो डिनोमिनेटर ले लिया और ये n न्यूमरेटर का आ गया. Any questions on equation 5? Okay, so any changes in reaction conditions that increase the right hand side will increase conversion, right? Because there is nothing but products upon reactants, right? अगर right hand side बढ़ा तो number of product का components moles बढ़ेगा, that is increasing the conversion. ठीक है? Any questions on equation 5? Okay, so let's see what is the effect of inerts using this equation. Okay, so if you dilute reaction mixture with inerts, suppose we add in ammonia नाइट्रोजन प्लस हाइड्रोजन प्लस से आर्गॉन ऐड कर दिया हमने, इनर्ट्स ऐड कर दिया कुछ, तो क्या हो जाएगा? इट विल इंक्रीज n, नंबर ऑफ मोल्स, टोटल नंबर ऑफ मोल्स इंक्रीज हो जाएगा, बिकॉज n इज नथिंग बट राइट समेशन ऑफ Ni प्लस समेशन ऑफ इनर्ट्स. सो नंबर ऑफ इनर्ट्स मोल्स बढ़ा दिया तो n बढ़ेगा, right? n बढ़ा तो this will increase conversion if nu is positive. Now if we take equation 5, n is in the numerator, right? Right hand side कब बढ़ेगा? When nu is positive, n to the power of nu. समझ में आया ये? Okay. That is, if the reaction proceeds with increase in number of moles, that means nu is positive, the presence of inerts will increase conversion, right? जैसे A goes to 2B देखा था हमने. In this case, if we add inerts, the number of moles n will increase. n increase हो गया, तो nu to the power of 1. n जितना बढ़ेगा उतना ये बढ़ेगा, पॉजिटिव साइड हो जाएगा. n बढ़ेगा तो ये राइट हैंड साइड बढ़ेगा, राइट हैंड बढ़ेगा बढ़े तो नंबर ऑफ मोल्स ऑफ प्रोडक्ट्स बढ़ेगा. So reaction will be favored. So increase will increase the conversion. So it is the opposite effect of this effect is opposite of increase of pressure. Pressure increase का क्या था हमारा? What is the effect of increase of pressure in this case?
Reduces the number of moles.
Yeah, reduces number of moles, right? Effect of pressure क्या था कि pressure बढ़ा रहे थे, it was trying to reduce the number of moles, right? But in this case, it is increasing it because nu positive है. So it is opposite of effect of pressure increase. ठीक है? Now, the presence of inerts will decrease conversion if the number of moles is decreasing in reaction, right? If you take nitrogen plus 3 hydrogen gives 2 NH3. In this case, nu is equal to -2. Barabar? So in this case, number of moles are decreasing. So what will happen is nu raised to power of -2 हो जाएगा और n raised to power of -nu हो जाएगा. If I add inerts here, ये -2 हो जाएगा, right? जितना बढ़ाएंगे उतना इफेक्ट उल्टा हो जाएगा. Right? Presence of inerts will decrease conversion if the number of moles is decreasing in reaction. क्योंकि राइट साइड रिड्यूस हो जाएगा, n रेज़ टू पावर ऑफ -2 हो जाएगा, राइट? ये -2 है, तो राइट हैंड साइड विल डिक्रीज. राइट हैंड साइड डिक्रीज हुआ तो अमोनिया कम हो जाएगा. ठीक है, समझ में आया इफेक्ट ऑफ इनर्ट्स?
Yes, sir.
Okay. Inerts will have no effect on conversion if nu is equal to 0. ये पहले भी देखा था हमने, राइट? nu इक्वल टू 0 बोला तो n रेज़ टू पावर ऑफ 0 हो जाएगा, तो देयर इज नो इफेक्ट ऑफ inerts. ठीक है. Any questions on inerts before we proceed to the next topic? Equation same use करने वाले हैं. We're just going to analyze it in different situations. Okay. So let us see what is the effect of presence of excess of reactants. Reactant ज़्यादा लिया तो क्या हो जाएगा? So we have seen K is equal to K upon K phi, P raised to power of minus nu, or K and Ky is equal to pi of Ni by N raised to power nu i. And we also seen that N is equal to summation of Ni plus N inerts. And ये सब देखा हमने, ये already done that. ये equation derive भी किया था हमने, right? So increasing number of moles of excess reactant, right? Excess reactant लिया हमने inerts में, initial में. It increase number of moles of product and improve conversion of limiting reactant. कैसे? Because n बढ़ेगा, right? n बढ़ेगा तो right hand side बढ़ेगा तो number of moles of product बढ़ेगा. ठीक है? Any questions? And that's what we had seen. जैसे conversion बढ़ता है, in excess reactant बढ़ता है, conversion बढ़ता है. So left hand side of 8 is the equation. Increase when number of moles of excess reactant increase. Therefore, we supply all reactants except limiting reactant in excess. Right? Always excess reactant is related to limiting reactant. To increase conversion limiting reactant. Any questions on this? Okay, so let's see what is the effect of products. Again, the same thing. Equation same ही है. If the initial reaction mixture contains any of the products, then the number of moles of product formed by reaction with equilibrium will decrease. Okay. This is ठीक है. So what will happen is if I just add products here, that means I'm adding this one in the feed itself. So ultimately reaction कम हो जाएगा because already वो present है. Equilibrium concentration fixed है, right? If I already have it in the reaction mixture, it will reduce the conversion because उतना कम बनेगा. Because it is fixed, right? This ratio is fixed. That is why products in the reaction mixture do not, or rather they have the reverse effect of reactants. The addition of products to original reaction mixture decreases equilibrium conversion. Reactants add किया तो increase होता है conversion. Products add किया तो decrease होता है conversion because already कुछ present है तो उतना कम बनेगा. We'll see all these examples by calculations. Effect of all these things, actual numbers you'll see, and then you realize what is the effect. Any doubts, questions? Take care. There are no questions. We'll stop here.